Our final objective on practice test C is a distributive practice looking at chemical and physical change. We will need to indicate if it is chemical or physical, explain the reason for our choice, and then if it is chemical, write the complete balanced equation. Our first and second will always be single replacements, some metal dropped into water, where we need to check the activity series as our tool. When copper is dropped into water, copper is below hydrogen on our activity series. It is not strong enough, therefore I will label it a physical change. Copper is below the water or on the activity series. Since it is a physical change, I will not write a chemical reaction for part C. The activity series is showing us that copper will not react with HOH, thinking about water. Copper is not strong enough to pick out H from water. Rubidium, however, is an alkali metal. It is in the first column on our periodic table. These are very, very active metals. This definitely, according to our activity series, will show a chemical change. Rubidium is more active than hydrogen in our water. Again, the tool there is the activity series. So if rubidium reacts with water, and again, writing that as HOH, shows me hydrogen and rubidium hydroxide being formed. Rubidium kicks out hydrogen, left is the diatomic molecule. Booking by charge, Rb is a +1, OH is a -1, and when we balance, 2, 2, 1, 2 fixes that equation. Question 1 and 2 will be single replacement. Check your activity series to determine if the metal is strong enough to react with water. Problem 3 and 4 will be similar. These will follow double replacement patterns. We want to use our solubility table to determine if we find a driving force. When potassium hydroxide is placed into a solution of calcium nitrate, I like to set up the two reactants so I can predict what my products would be and begin searching for a driving force. Potassium would hook to nitrate, KNO3, based on charge, +1, -1. And calcium hooks to hydroxide, CaOH taken twice. Now, if this is indeed a chemical change, I need to identify that one of those two has a driving force. We look on our solubility table. Calcium hydroxide, CaOH taken twice, says that it's slightly soluble, but it is not red on the solubility chart. KNO3 is not red on the solubility chart. Neither one of these are solid precipitates. Therefore, there is no driving force. This would be considered a physical change, and my reason for knowing is there's no driving force for this reaction. Let's consider question 4. Aluminum nitrate, Al+3, NO3 -1, AlNO3 taken 3 times, placed into ammonium nitrate. Do you hear that they have the same last name? Aluminum nitrate, ammonium nitrate. If they switch partners, you'll make aluminum nitrate and ammonium nitrate. That's nothing new. This is a physical change. And my reason? No new substance formed. If two ionic compounds have the same first name or the same last name, you will not make anything new by exchanging partners. And the last question will be a combination where we are looking for activation energy. If aluminum and sulfur are placed in a test tube together and heated strongly, it will force a chemical change by providing activation energy. In our combination pattern, we will start by writing aluminum, Al, with the sulfur. In a combo pattern, when a metal hooks to a nonmetal, it does so by charge. Al with its +3, S with a -2, so our product would be Al2S3, and then we would simply balance with our coefficients on the left-hand side. 2 to 3 to 1 balances that equation.